Right, so here's our transformation extension sheet. We're performing the transformations on a grid. So if we start with 1A, we're going to translate A, that's the point there, by vector 1, 2 to give us A dashed. Now vector, so that's 1 across, 1 to the right, and 2 up. So if we take point A, we're going across 1, up 2, it would have the coordinates 2, 4. Right, let's try B. It's negative this time, so we're going back 1, and then we're going down 4. So start with B, back 1, 2, 3, down 4. B dashed, that would have coordinates negative 4 and negative 3. Right, I'll try one more. Perhaps I might go down and do F. So I've done those two. Hop down and do the last one. We're taking point F. We're doing the vector back 1 and down 1. Back 1, down 1. And then, straight away from that point, we're doing a second vector that goes back 2 and down 2. So from that point, we've already gone back 1, down 1. This time we're going back 2, down 2. And actually I end up back at the origin, which has the coordinate 0, 0, 0 on the x-axis and 0 on the y-axis. That's the origin point. Right, having a go yourself, what vector translates A, here's A here, to A dashed? Well, I can see that we need to go across 1 to the right, so it would be across 1, and then we're going down 2, minus 2. You can pause in a minute and try those as well. And just to show you how to do number 3, this time we're reflecting. We're reflecting point A in the x-axis to give us A dashed. So here's the x-axis. You might like to put a ruler or a mirror along that line and have a think about where A is going to go into. So it goes into the mirror at 90 degrees to the mirror line, perpendicular. 2 squares in, 2 squares out. The reflection A dashed would be at the point negative 3 on the x-axis, down negative 2 on the y-axis. So the point negative 3, negative 2 will be the point A dashed. So I've done A. I'll have a go at C. Here's point C here. We're reflecting in the x-axis first, so perpendicular into the x-axis. 1, 2, 3, 4 squares. 1, 2, 3, 4. The image will appear back here. That's C dashed. And then straight away we want to reflect C dashed in the y-axis. So this time I'm going to put my ruler or mirror along this axis. From this point here we're going into the mirror, 1 square, out 1 square, C double dashed will appear to be back here. Now the coordinates of C double dashed, the x coordinate always comes first in the coordinate pair, so the x coordinate is minus 1 and the y coordinate is minus 4. Now once you can pause and have a go at B. Now once we get down to these ones here, we're reflecting point D, but this time we're not doing it in an axis, we're doing it in a line, the line y equals 1. So we need to think about where the line y equals 1 would be, what it would look like. There's a hint actually at the start of the question here, it is a horizontal line. The reason is because what you need to do is find 1 on the y-axis. So here's the y-axis, here is 1 on the y-axis. So all the way along here, all these points along here would have a y-coordinate of 1. They have different x values. For example, this point here would be the 0.21. This one here would be the 0.41. We'd have 3.5 in here, and 1. All those points have a y-coordinate of 1. So the line y equals 1 actually is going to be a line across there. Y equals 1, you can draw it in. Imagine putting a mirror along there, and we want to reflect this point D into the line, into the mirror, out the other side, and the image would appear to be back here at this point with coordinates 3 on the x, 2 on the y. 3 on the x, 2 on the y. Remember, x comes first in the coordinate pair. and you could have a go at E. This time it's the line x equals 1. So we go to the x-axis and find 1. I might just eliminate some of what we've already done so it's less cluttered. Obviously you can't do that, but I can. So the line x equals 1, we find 1 on the x-axis. All these points along here will have an x coordinate value of 1. For example, this point here that I'm circling would have the coordinates 1, minus 3. And this would be the point 1, minus 3.5. So all the points along this line satisfy y equals 1. Quite hard to draw a neat horizontal vertical line on the computer. It's the line x equals 1. And now we're reflecting point E. So into the mirror line at 90 degrees, out the other side, 1, 2, 3, 1, 2, 3. E dashed would be the point 4 on the x axis, negative 2 for its y coordinate. And lastly, F, I might just erase just to help us see. I know you can't erase it. So if we take point F, we're reflecting it in the x-axis. So if we were to put our mirror or a ruler along the x-axis there, you'll notice that the point itself is actually on the mirror line. So it's not going to go anywhere. Points on the mirror line stay where they are. The reflection appears to be on top of it. The coordinates of point F, 1 on the x, 0 on the y. Now you can go back and finish this side of the sheet.